right now, there could be a civilization a billion years older than ours. Old enough to have watched galaxies collide like slow-motion fireworks. Old enough to have invented and abandoned entire technologies before our sun had even finished forming. Old enough maybe to have already found us and simply chosen, for reasons we can't yet imagine, to stay quiet. So, why hasn't it said hello? It's the kind of question that sounds like science fiction until you realize serious physicists have spent careers trying to answer it with equations, not imagination. And here's the strange part, the part that should make the hair on your arm stand up a little. The same laws of physics that make it almost impossible for anyone to ever reach us are the exact same laws that tell us, with cold, testable precision, what would happen the moment they did. Impossibility and inevitability, sitting on the same equation, staring at each other. That's not a contradiction science tiptoes around. It's one that physicists have quietly wrestled with for 70 years. Ever since a lunch conversation in 1950 turned into one of the most famous unanswered questions in all of science. And by the end of this video, you'll understand why the honest answer to what happens if aliens reach Earth has almost nothing to do with spaceships, laser beams, or invasions, and everything to do with something far stranger, time itself. Think about the last time you looked up on a genuinely clear night, away from city light, when the sky actually shows you what it's got, thousands of points of light. And every single one of them is, in a small but very real way, a lie. You're not seeing the stars as they are right now. You're seeing them as they were. Sometimes a few years ago, sometimes thousands of years ago. The light only now wrapping up a journey that began long before you drew your first breath. Some of those stars might not even exist anymore. They could have collapsed, exploded, gone dark decades or centuries ago, and you have no way of knowing, because the news hasn't arrived yet. You are quite literally peering into the past every single time you look up. That's the part most people forget when they picture aliens making contact. We imagine it like a knock on the door, sudden, immediate, happening now, the way a doorbell rings and you answer at the same second. But space doesn't work like your front porch. It works more like a library where every book takes centuries, sometimes millennia, just to arrive on the shelf. And by the time you read it, the author who wrote it might be long gone. If a civilization sent a signal from a star 4,000 light years away, they sent it before written language existed anywhere on Earth, before the pyramids, before agriculture. If they're sending something as data-heavy as video, they are right now, in this exact moment, broadcasting the equivalent of ancient history into the void with absolutely no idea whether anyone will ever be listening on the other end. This is why we build enormous dishes to listen for exactly this kind of ancient mail. Arecibo, before its collapse in 2020, spent decades scanning the sky. Facilities like China's Fast Telescope, the largest single-dish radio telescope on Earth, continue that work today, not because anyone seriously expects a live conversation, because the geometry of the universe simply doesn't allow one. And this is where the first real crack appears in how we usually imagine this whole scenario. We picture reaching Earth as an event, a single moment, a headline, a before and after. Physics insists it's closer to archaeology. Digging up a signal or a ship or a probe that was sent so long ago, it belongs to a different era of that civilization's own history. So, here's the question hiding underneath the question everyone actually asks. It's not really could aliens reach Earth? That's the easy version, the one that fits in a movie trailer. The real question is stranger. What does reaching even mean? In a universe that refuses to let anything happen instantly, because if nothing, no ship, no signal, no flicker of information can move faster than light, then every possible form of contact is, by definition, contact with the past. A civilization can't reach us as they are today, existing right now, thinking their current thoughts. They can only reach us as they were sometimes so long ago that their entire civilization might not even exist anymore by the time the message or the machine or the light finally lands here, which raises something genuinely unsettling to sit with for a moment. It's entirely possible we've already been reached and simply didn't notice. A radio pulse could have swept silently past Earth 1,000 years before the first dinosaur ever walked, sent by a civilization that rose, thrived, and vanished long before humans existed to catch it. There's no ceremony required for physics to have already delivered the mail. The only real question is whether anyone was standing at the door, awake, listening at the exact moment it arrived. It's a bit like leaving a lantern lit in a window for a guest who was invited so long ago that the invitation itself has crumbled to dust. And yet the lantern burns on anyway, faithfully, just in case. Now, here's how most people are taught to think about this problem in school, and to be fair, it isn't wrong. It's just incomplete, like reading the first chapter of a book and assuming you know the ending. Light travels at roughly 300,000 kilometers per second, 186,000 miles per second, if you prefer. And here's the rule that nothing with mass can ever break. As an object's speed climbs toward that number, its effective mass, and the energy required to keep pushing it faster, climbs toward infinity right alongside it. Get a spacecraft to 99% of light speed, and squeezing out even 1% more will require more raw energy than exists in every star we can currently see combined. So, the textbook answer to why haven't aliens shown up is refreshingly simple. Distance is enormous. The speed limit is hard and unbreakable, and civilizations, even ones far more advanced than us, are boxing by exactly the same universal ceiling we are. Our nearest possible neighboring star system, Proxima Centauri, sits about 4 light-years away. At the fastest speed any human-built spacecraft has ever managed, the Parker Solar Probe, slingshotting around the sun, that trip would still take somewhere on the order of 7,000 years. And that's our closest neighbor. Not some distant ancient civilization on the far side of the galaxy, 100,000 light-years across. It's the explanation that gets taught in classrooms, and it's a genuinely reasonable one. Space is unimaginably big. The speed of light is comparatively slow when measured against that bigness, and biological creatures with lifespans measured in decades don't casually undertake journeys measured in tens of thousands of years. Case closed, right? Except that explanation is quietly built on top of one hidden assumption, an assumption so intuitive that almost nobody questions it, and one that physics is about to demolish completely. The hidden assumption is this: that time passes the same way for the traveler as it does for everyone watching from back home. It doesn't, not even close. This is where Einstein's relativity stops being a dusty textbook footnote and becomes quite literally the strangest travel brochure ever written. If you could build a ship capable of reaching close to light speed, say 99.9% of it, something remarkable happens to your experience of time relative to Earth's. Time dilates, slows down from the outside perspective. For you aboard that ship, a journey that looks like it takes 4 years from Earth's point of view might feel to your own body and your own clock like only a matter of months. Push that number even closer to the ceiling, and the effect compounds in ways that stop feeling like a rounding error and start feeling like magic. A sufficiently advanced civilization capable of sustaining speeds around 99.999% of light could in principle cross the entire visible galaxy, a distance that takes light itself roughly 100,000 years to travel, while the crew on board ages only a handful of years. They'd step off the ship younger, in a real measurable sense, than the grandchildren of the people who waved them off. Here's the paradox sitting right at the center of all this, quiet but enormous. From the traveler's own point of view, interstellar travel isn't impossible at all. It's almost easy. It's only impossible from the point of view of everyone left behind. Everyone forced to experience the full, brutal, uncompressed passage of every single year, while the traveler experiences almost none of it, which means the real barrier to alien contact was never really distance, not in the way we assumed. It was always this: could a civilization build something that survives long enough and accelerates hard enough to let Earth's outside clock race ahead, while their own clock barely moves at all? Let's actually run the numbers. Because vague statements about relativity are easy to nod along to and hard to actually feel until you see the specific trade being made. Imagine a ship departs a star system 500 light-years away, cruising at 99.99% of light speed. From Earth's perspective, watching the outside clock, the trip takes just over 500 years to complete, 5 centuries minimum, no matter how advanced the technology. But on board the ship, thanks to time dilation, the crew experiences something closer to 7 years passing. 7 birthdays celebrated in a metal hull, while outside, 500 years crumble away behind them. Kingdoms rise and fall in that gap. Entire technologies get invented, perfected, and discarded as obsolete. Everyone the crew ever knew, parents, friends, entire generations back home, will have been dead for roughly 400 years by the time the ship even reaches its halfway point. They left as contemporaries of their own civilization and would arrive as something closer to time travelers, strangers from a past nobody at their destination remembers. Now, stretch this thought experiment even further. What if the civilization that built the ship isn't decades ahead of us, or even centuries, but millions of years ahead, old enough to have already solved propulsion problems we can't yet properly conceive of? At that point, arriving might not look anything like a spaceship gliding into orbit. It could look like a probe the size of a grain of sand, self-replicating, endlessly patient, engineered to sit quietly in a solar system for millions of years before doing anything at all, waiting, essentially, for someone intelligent enough to notice it. Serious physicists have proposed exactly this kind of scenario. Some have suggested that if contact ever happens, it may already have happened quietly, patiently, and we simply haven't recognized the seed sitting somewhere in our own solar system yet. So, here's the question worth actually sitting with, not just skimming past. If the physics genuinely allows for contact, just not on any time scale a human mind finds comfortable or even graspable, is aliens haven't reached us actually a true statement? Or is it just aliens haven't reached us yet on a clock we were never built to read? Let's go one layer deeper still, because relativity isn't the only law quietly working against it. And, in a strange way, working for it, there's a possibility of contact. There's the Fermi paradox itself, named after physicist Enrico Fermi, who reportedly raised a question almost as a joke over lunch with colleagues in 1950. Given the sheer number of stars in our galaxy and the staggering age of the universe, over 13 billion years, more than enough time for even one early civilization to spread across the galaxy many times over. Where is everyone? Why is the sky, statistically speaking, so quiet? One serious attempt at an answer involves something called the Drake equation, a framework that multiplies together the rate of new star formation, the fraction of those stars with planets, the fraction of those planets capable of supporting life, and, critically, how long a technological civilization tends to actually survive before it destroys itself, goes silent, or simply moves on to communicating in ways we can't detect. If that final number, civilization lifespan, turns out to be small compared to the age of the universe itself, then advanced civilizations might be common across cosmic history, yet rarely, if ever, overlapping in time. Two lighthouses can exist on the very same ocean and never once see each other's beam if one burns out before the other is even lit. Then there's the raw thermodynamic brutality of the trip itself. Even the most optimistic near-light speed ship has to shed enormous waste heat, survive collisions with ordinary interstellar dust that at relativistic speed strike with the force of small nuclear detonations, and carry shielding heavy enough to withstand years of unfiltered cosmic radiation exposure. Every one of these problems is in principle solvable, but in principle in physics very often means with technology so far beyond our current understanding that it looks to us indistinguishable from magic, which means that if contact ever genuinely happened, it almost certainly wouldn't look like the sleek ships and laser battles of the movies. It would look like something engineered around the exact same physical laws we already understand today, just executed at a scale and with a patience that we can barely begin to imagine. Let's zoom out now, far enough that the numbers stop feeling like statistics on a page and start feeling like genuine vertigo. Our galaxy alone contains an estimated 100 to 400 billion stars. The observable universe beyond that contains roughly 2 trillion galaxies. If even one star in a billion ever hosted a civilization that became spacefaring, a wildly conservative, almost pessimistic estimate, that's still potentially hundreds of civilizations across our galaxy's 13 billion year history. But here's the piece that quietly reframes the entire question. The galaxy isn't just big in space. It's equally big in time. A civilization that rose and peaked 200 million years ago, back when dinosaurs were still walking Earth, long before a single primate had climbed down from a tree, could have already risen, explored, spread, and gone extinct, all before humans existed to ever notice they were there. From our perspective, that entire civilization simply never happened. Its contact window with us never opened because we weren't standing anywhere near the door yet. This flips the whole question inside out. It's not just, are we alone in space? It's, are we alone in time? The universe could, in theory, be genuinely teeming with intelligent life across the whole of its history, and almost none of it ever overlaps with any other. The way two people can live 70 years each in the exact same city and never once cross paths, simply because they were born 4 decades apart. Distance turns out to be the easy problem. Timing is the one that might actually be unsolvable. Here's the insight that quietly changes how you look at the night sky, maybe for good. Contact was never really about distance. It was about timing. Physics put a hard, unbreakable ceiling on speed. Nothing gets around that, no matter how advanced the engineering. But it doesn't put any ceiling at all on patience, on cleverness, on the sheer creative persistence of a civilization old enough to have already solved a problem that looks impossible to a young species like us. Given long enough, not years, not centuries, but the kind of time scales that make human history look like a single afternoon, the impossible barrier of interstellar travel dissolves into something closer to merely extremely difficult, extremely slow, and extremely expensive. And extremely difficult and extremely slow is exactly the kind of problem a civilization with a million-year head start could shrug off, roughly the way we now shrug off building a bridge that takes a mere decade to complete. What actually stops contact more than raw physics ever could might simply be the overlap problem. Two civilizations needing to exist, be aware, and be listening during the exact same vanishingly thin sliver of cosmic time. Not impossible. Just improbable enough that in a universe 13.8 billion years old, we might genuinely be the first ones home, or the last ones still awake, or simply mistimed by a margin of a few million years, which, measured against a cosmic clock, is close enough to count as a photo finish. And if that's true, then the silence we hear when we point our telescopes at the sky isn't necessarily evidence of emptiness. It might just be evidence of bad timing on a scale too vast for any single human lifetime to properly feel. Which leaves us with something quietly strange to sit with long after the video ends. If contact ever happens, it won't be sudden. It won't look like the movies. It will be the tail end of a message that began before we could possibly imagine, light or a probe or a signal having crossed a gulf so vast that by the time it finally lands, the civilization that sent it may be unrecognizable, radically transformed, or simply gone entirely, extinct long before their own message finished its journey. In a strange way, receiving a signal from another civilization would be a little like receiving a letter from someone who might have already lived an entire life and died in the years between writing it and you finally opening the envelope. Contact, if it ever comes, may not connect two living worlds at all. It may simply connect a memory to a future. A hello from the past arriving at a moment its author never gets to witness. Does that make the universe lonelier? Or does it make every faint unexplained radio is picked up by a telescope somewhere in a quiet desert secretly more important than we usually treat it? Because somewhere in that static, in that noise most of us would never hear about, there might already be the only sentence a long-dead civilization ever managed to send us, arriving in its own strange way right on time, just centuries or millennia too late for anyone to answer back. So, maybe the real question was never why hasn't anyone come. Maybe it's this. What would we even recognize as an answer if it arrived? A signal older than our species. A probe that's been quietly waiting since before the continents wore their current shape. A hello sent by something that no longer exists to hear us say it back. Somewhere out there, right now, in this billion-star silence, someone might already be listening back. Keep watching the sky. It's still writing to us.